Hello viewers, Alan here, welcome back to the workshop. So I'm going to get back onto the Lynx15 in this episode and girded the loins, so I'm going to have a go at the camshaft. So I haven't done one of those before and I found the camshaft drawing a bit intimidating with all the angles, but I'll have to get through it somehow, and I'm sure Greg will be supportive and I'll probably need his help. Anyway, we're going to start by making a blank for the camshaft on the lathe, and I've got a piece of stock here. This is actually a chunk of 1 inch diameter hydraulic cylinder rod, so it's tough stuff to begin with, you know, hard outer skin over 4140. But let's get over to the lathe and get started. So we'll start by stripping off the outer layer of chrome and induction hardening. Just do a couple of tentative cuts here to see what configuration works best. Alright, we'll go with a 0.2 depth of cut to start with, I think. Actually, could try a bit deeper. So that's got rid of the hard chrome and the start of the hardening. So we'll see where we're at. I had it set for 24.8, but that's sort of like a sighting run. 24.74. So I think we'll aim for 24 this time. And we should be through most of the hard layer by then, I would think. So we're aiming for 24 with that pass. Well, that's a bit freaky. It landed right on it. I've got to get this down to 16 millimeters, so quite a bit. So I think we'll see if we can get a bit more ambitious now and take a millimeter depth of cut. Well, that's a gorgeous surface finish. It's like highly polished. Yeah, there's quite a bit of heat in that now though. So that was set for 22, but it's quite warm, so I don't know what we'll actually have here now. 21.98. Alright, so we've gone undersized a bit with that much heavier cut. So we're obviously way past through the hard stuff and into unhardened 4140. And it's just cutting beautifully. Right, I want to realign the tailstock because I think it's drifted off the centre line slightly. My chosen method is a bar with a collar on each end. Take a cut across both collars at the same setting and you should finish up with the same diameter. So I've had a couple of goes at this and let's see what we're getting. Alright, we've got 27.994 there, and up this end I'm going to hold that so you can see it. There you go, it's also 27.994, so it isn't going to get much better than that. So we can take this out. Tailstock's now correctly aligned. Okay, so I've got my blank down to 16 millimeters, one end to the other. In fact, it's deliberately slightly over. We've got 16.02. So that will give me a little bit of leeway when I come to clean up the camshaft. That 0.02 will allow me to do a bit of clean up on the lobe. Anyway, so I've got to get this down to 8 millimeters now for 35. So we'll take millimeter depth of cut. So first pass we'll take this down from 16 to 14. I think we'll sneak up on this. I'll go at 8.02 and see what we get. it can't be too tight, and if it's too loose it's useless, so I really need to sneak up on it. I did see some small amount of material scraped off. And a little bit has come off. Well, that has definitely started on. Whether you can see that it has actually pushed on. But the question is it still too tight? Let's just try polishing it a bit more. It's got to be pretty darn close. $7,988. That might be just the ticket. Oh, look at that. That's perfect. I just need to clean that corner out so the bearing can sit right up at the shoulder. Okay, call that a success. Okay, so now I've got a couple of smaller diameters to do here leading up to the side of the first cam lobe, and then a lump taken out between the two cam lobes for weight saving, and then I'll be turning this whole lot around and machining from the other end. I don't believe these diameters are critical, and this first one I'm shooting for, I'm aiming for 10. That should be about 12, 11.995. So we go in at 10 now. So that's the first of them down to 10, and then I'll do another one to reduce to a 9mm step. I'll just do a quick check, see where I finished up. That's going to be pretty close to 10 now, I reckon. You've got to laugh when that happens. Alright, let's go in for 9 now. I'll do this in one pass, I think. 9.09, well that'd be good enough. Like I say, it's not a bearing fit or anything like that. It's just the stop that the bearing will come up against. So that's finished this end, just deburr it. Oh no, I've got to do the big groove in the middle here, right. So that's the first pass, down to 10.1. I'm going to check 15 times before I cut once here. Well, that's 10.1 all over, so now I've got to run a clean up pass at full depth. Oh, and hopefully that's 8 in there. Or somewhere near it. I've got to get a gauge block and check it properly. Alright, well that's a stack at 7.97. So we're slightly undersized, but I think, let's just check that, yeah, 7.97. So I don't think it matters that I'm just slightly small, so we'll leave well alone there and move on to the next feature. No, and of course I should have checked the diameter that we finished up with. We were supposed to be getting 10 here. It's only nominal, but still shooting for 10. 10.04. No, that's close enough. I'm happy with that. Right, so I've mounted my camshaft blank in this setup, so I can mill the lobes into shape. So the basic idea is to rotate in 5-degree increments and mill off flats. So at the end of it there'll be 72 steps with 5-degree increments, and hopefully we'll finish up with something that looks like a cam lobe waiting to be cleaned up with emery paper. So I've used the dial gauge to get the camshaft horizontal. It's a bit fiddly finding the high points, but there we go. So that's got it horizontal. And the other part of the deal is I need some registration or indexing. So I've made this piece up to do that job. The idea is to lock it onto the shaft. There is actually a little brass plug under that screw. This will just knock this up out of a bit of scrap. Probably made it a bit more elaborate than it needed to be, but nonetheless. So I've locked the dividing head at 0 degrees. I'm using it as a rotary table really. But anyway, it's locked at 0, so now I want to set this registration thing parallel, or yes, flat, parallel, while that's locked at 0. So if we come across here, move. So we need to go up a bit. I'll fiddle around with that and I'll bring you back when I've got this level. So I think I've got this set as well as I'm going to get it now. Level across there. So Greg laid out the design of the camshaft in this fashion, and I wasn't sure how I was actually going to make that, but I did some poking around on the internet and came up with a method that was demonstrated by George Britnell, and I've put a link to his method in the description. And as I mentioned before, it's basically a matter of milling a succession of flats at incremental rotations. In this case I'm using a 5-degree increment. And when I discussed this with Greg, he was quite happy to produce the table of set-offs so that I could do that. And so I'm ready to get started with that. What's going on here? Something's moving here. I have to find out what. Right, well it seems like Murphy was busy making somebody else's life a misery. I had forgotten to tighten the hold down bolts on the dividing head, and so under the pressure of the cutter the whole lot slid that way. But thankfully nothing came loose here or there, so I didn't lose any alignment. So I've just tightened everything back up again and we should be good to resume. I hope. I doubt that the cutter will pick up exactly where I left off, but I was doing it in 3 slices. So this second slice at 6mm, I've still got a bit to go, 0.4 or something to go, so hopefully we'll be alright. And this will be the last cut to depth. That cutter's, I should notice that before, that cutter isn't doing a very good job. I'll have to swap that out. Right, I've switched out the cutter, so let's see if we can get on with it now. So this cut will be at 5.62. For correct results, all the milling cuts need to be done tangential to the cam surface, and that's what the tapping contact will be. We'll do our first 5-degree rotation. And this requires cutting offsets to be calculated independently for each incremental rotation. Otherwise the engine will be running backwards. Fortunately, I was able to find an Excel spreadsheet that will do this. I'm not sure exactly who should get the credit for it, but I have included links to the spreadsheet and related documents in the description. So let's sort of finish the base circle now. We start taking progressively less metal off until we finish up with the lobe around here. Right, well let's finish the first cam lobe. It's a little bit pointier than I was expecting to see. So looking more closely at this cam, I've realised it's malformed. You can see there's a sharp ridge instead of a rounded nose, and this was due in part to using 5-degree steps all round, and clearly these were much too large for the nose area. But there's also another problem. The machining coordinates defined a set of points on the cam surface, and the milling cutter joins these dots with straight lines or chords that cut below the required surface. It turns out that for correct results all of the milling cuts actually need to be tangential to the cam surface, just like the tappet contact will be, and this requires the cutting offsets to be calculated independently for each incremental rotation step. Fortunately, I was able to find an Excel spreadsheet that will do that. I'm not sure exactly who should get the credit for this, but I have included links to the spreadsheet and the related documents in the description. So I'll have to cut another cam blank and have a second try. Right, so I've made another camshaft, and after a lot of deliberation, footsing about and discussions with Greg, who by the way has been incredibly patient and helpful, I'm good to go. What I've decided, and I've established a new table of offsets which I'm going to use, and I'm going to use 1 degree steps for the cam lobe and 2 degree steps for the base circle. So I've already levelled it off here to get the base circle to the base circle depth, and so I'll start my 1 degree increments now. Right, so that's finished machining the exhaust lobe, and at least it looks like a proper cam now instead of this pointy nonsense that I got the first time round. I'm pretty sure that so obviously I worked with a revised set of lifts, but I think the major change really was just switching to 1 degree increments for the lobe and 2 degree increments for the base circle. Anyway, I think that'll clean up nicely enough, or easily enough, with emery paper. Right, so I'm getting ready now to machine the inlet cam, and you may have gathered I've really struggled with this doing this camshaft. This is my second go, and I don't know why. I must be getting dopier with each passing year, I think. But anyway, if I've correctly absorbed and understood all that Greg has been telling me, very patiently I might add, deserves a medal for patience, that man. Then the key to this is recognising that the inlet and the exhaust cams, lobes, can only be correlated at the point of maximum lift, which in this case is 110 degree separation between the two. So that would suggest you have to rotate this lot 110 degrees before machining. But there's actually more to it than that. The two lobes are different shapes. The inlet lobe has 10 degrees less duration than the exhaust. Effectively that means it's a little bit skinnier and has a pointier nose. So I think to get this to the correct position for machining, I have to rotate by the 110 plus 5 to make up for the difference in the shape of the two lobes. So I'll rotate this whole lot 115 degrees and start machining, and fingers crossed that I've got it right, because I don't want to have to do this for a third time. So first move is to machine a flat at the level of the base circle diameter. So I've got to come down 2.4 millimeters for that. So now we start the 1 degree increments. Right, well that's just taken the last cut, and I guess it's looking like a camshaft, and it looks like the lobe's in the right place. I'm just wondering whether I should try to find some way of marking top dead centre while it's still in the setup. Anyway, I'll worry about that, then I'll whip it out, clean it up, and we'll have a closer look. So I think it's looking pretty good, and I'm going to clean the lobes up with 180 grit paper. I've already started over there. So that the tooling marks aren't very deep at all. Very noisy birds in the background, but I think you can see that's already cleaning up just from that small amount of rubbing. I'm trying to put the pressure evenly around the circumference of the thing. It would be very easy to focus on the two high points, but obviously I don't want to do that. This lobe only has a 1.1 millimeter diameter radius on the end, so it's quite sharp, and I don't want to lose that. That's what the designer wants, that's what we've got to try and give him. So I think we'll leave the rest of that for finer paper. Right, after a bit more emery paper and some Scotch-Brite, there's a few very minor scratches left, but the shape's good, and I think those surfaces will get the job done. Okay, time to see whether the camshaft will fit in the cam box. Oh, look at that. That's perfect. Well, I can assure you that felt pretty darn good when this lot went together. This camshaft has been kicking my butt, and it was really making me feel like I'd lost the plot. So it was very pleasing to see it all go together. Well, I'm going to stop there. I'll quit while I'm ahead for this episode. I hope you found some bits and pieces in there that were entertaining, perhaps helpful, I don't know. Laughed at some of my endeavours. But I've obviously made quite a bit of progress with this engine now, and there's really only a few small bits and relatively small bits and pieces left to make. So thanks for joining me, and I hope you'll join me again for the next episode when it'll really start coming together, I think. Cheers.